Let's try going over this problem about a binary tree. So the prompt says, imagine a binary tree where each node contains an integer. The goal is to find a path from the root to a leaf such that the sum of the values of the nodes along the path is maximum. And we're also given this data structure for a tree node, and we can see that it has an integer value and a pointer to the left child and pointer to the right child of that node. And here's a function that we need to fill out, max path sum. So before we start writing, let's try and get a bit of intuition for the problem. So let's remind ourselves what we know about binary trees. A node in a binary tree can have 0, 1, or 2 children, which explains why we have a left tree node pointer and a right tree node pointer in our data structure. And what would a single root to leaf node path look like? Well, this is the root of the tree, and these are all leaves in the tree. So one possible root to leaf node path would look like this. Start at 10, go to 5, go to 2. Another valid root to leaf node path would look like this, 10 to 15 to 13. We could also do 10 to 5, 5. And we could also do 10, 15 to 25. And now we've covered all the possible root to leaf node paths in this example tree. What's important to note here is that there are many possible root to leaf node paths in the tree. So how do we find the maximum path sum for a tree? Well, to do that, we would need to find the sums of all of the root to leaf node paths in the tree, and then determine which root to leaf node path has the largest sum. So we know that recursion is a really good fit for traversing a tree because it lets us handle one node in the tree at a time. So let's write max path sum as a recursive function and see what we can do to write something that will traverse all of the root to leaf node paths in a tree. So how do we approach writing any recursive function? We think about space case, the recursive case, and of course the recursive leap of faith, which is where we're actually going to make the recursive function call. So let's start with the base case. What if the argument is a null pointer? What if the node that's passed in is a null pointer? If root equals null pointer, then what would we do here? Well, this means someone called max path sum with an empty tree, or we just traveled down the tree until we hit the end of the path and there are no more nodes left to recurse on. So if it was that second case, it would be something like we went from 10 to 5 to 2, and then we tried to find its left child, and we discovered it doesn't exist. So this root is a null pointer in that case. So whether we got past an empty tree or we kept recursing until we got to past a leaf node in the tree, we know that there's no path starting or continuing at this node because this node is null pointer, it's non-existent. So the sum for this path is just 0. We would return 0. Okay, so now let's address the recursive case. What if we're given a node that's not null pointer? What if it's a valid node in the tree? Like here, for example, 5 in this tree would be something that would cause us to enter the else part of this if-else statement. Since it's a valid tree node, it's possible that there's a non-zero sum path if we follow this node's left or right child. So here's a possible choice. Do we follow the left child to get the maximum path sum, or do we follow the right child to get the maximum path sum? This is a question we have to answer if we're trying to find the maximum path sum for the entire tree, right? Well, this is actually where the recursive leap of faith comes into play. We don't actually need to choose a single path to follow. We can take both the left child's path and the right child's path and figure out which one gives us the higher sum. We can do that using 2 recursive calls. one for the left child and one for the right child. Let's see, int left sum. What is the sum we would get if we followed the left child? This is where we call max path sum. Max path sum root arrow left and int right sum equal to max path sum root right. So now using the recursive leap of faith, we found the maximum possible sum we could get if we followed the right child, and the maximum possible sum we could get if we followed the left child. And now that we have both values, we can figure out which one gives us the higher sum. Int max sum is equal to max left sum right sum. Finally, let's figure out what to return here. So the greatest possible value for a path that includes this current node that we're on right now is this node's value plus the maximum sum from following either the left child or the right child. So we would return something like this. Return this node's value, root arrow val, plus the maximum possible sum you can get from recursing further on this node's children. Max sum. Awesome. So now that we have a draft, let's visualize what we just wrote. We can use this example here again. If we called max path sum starting at this root node, it'll explore as far along one branch of the tree as it can and then start backtracking. It'll go left, it'll go left, it'll go left. It'll see that 2's children don't exist, so it'll start backtracking. And then here, it's going to explore the second branch, and then it's going to backtrack all the way back to the root node. And now we're going to explore the right child of this root node. We're going to go here, go all the way to 13, come back here, go all the way to 25, and come back here, and then go all the way back to node 10, and then that would give us our return value. So as we can see, we explore one branch fully as deep as it goes at a time, one branch at a time. This is what we call depth first search.